Hello everyone, it's Jay, and today we'll be working through problem 2 on your pre-workshop sheet. So as always, I'm going to read the question and highlight the important information. So wind fires a beam of Ne plus ions with mass 23 AMU through a magnetic field and records the deflection. We are told that they then remove an electron from each of the atoms and that by beta decay, which is a type of radioactive decay, one neutron turns into a proton. Now, we are asked that if they take this new ion and fire a beam of it through the same magnetic field and at the same velocity as before, what factor would the deflection change, and what is the name of the new ion? So let's start with the name, and let's go over how naming works in general by working through the name for our initial neon plus. So we start by writing the periodic table symbol for our element. So we have neon, which is Ne. Now, in the top right, we place our charge. So here we are told we have a charge of plus, which is shorthand for a 1 plus charge. And in the top left, we are going to put the atomic mass. So we are told that that's 23 AMU. And that gives us how we name our atoms. So we know now that our atomic mass is comprised of protons and neutrons. Our electrons' masses are negligible, and a proton and a neutron both weigh 1 AMU. So we need to figure out how many protons and how many neutrons we have. Our number of protons is the same as our atomic number, and we can find our atomic number by looking at the periodic table. So neon is atomic number 10, therefore we have 10 protons. Now, we know that the 10 protons contribute 10 AMU out of our total 23, so we must have 13 neutrons. And now we want to figure out the number of electrons. So we see we have a plus charge here, and our charge is comprised of protons and electrons. And our protons are a plus 1 charge, our electrons are a negative 1 charge. So if we have a plus 1 charge on our atom, we must have one more proton than electron, so we have 9 electrons. Alright, so this is what we start with. Now, we are told that one neutron is converted to one proton by beta decay, and we lose one electron. So, if we look at our final state now, we are going to have 11 protons, 12 neutrons, and 8 electrons. So now let's work backwards to find this name. So with 11 protons, we look at our periodic table for atomic number 11, and we'll see that this is a sodium atom. So if we have 11 protons, which contribute 11 AMU, and 12 neutrons, which contribute 12 AMU, our total mass is going to be 11 plus 12, or 23 AMU, so the same mass as our neon. Lastly, our charge. Our charge is going to be our number of protons minus our number of electrons. So 11 minus 8 gives us 3 protons remaining, so 3 plus charges. And this is the name of our new ion. So now let's solve for the factor of deflection. Alright, so now let's solve for our deflection. When we solve deflection problems, we want to write out our proportionality expression. Deflection is proportional to charge times velocity times magnetic field strength times 1 over mass, and we'll do a semicolon for mass so that we can deal with the mass separately. Now let's finish filling out our proportionality table. We know that we are dealing with 23 neon plus to start, and we end with 23 sodium 3 plus to finish, and as always, we're going to put in our factor line. And now let's solve from left to right. So we know, starting with charge, that the charge of the neon plus is 1 plus. And we know that the charge of the sodium 3 plus is 3 plus. So the factor for our charge is going to be 3. Now, the blue information tells us that that's the same magnetic field and same velocity for both ions. So our factors for velocity and magnetic field strength are going to be 1. Now we just need to solve for the factor for 1 over the mass, and we can do this by working with the factors for the mass. So the mass of our 23 neon is 23 AMU, And our mass for our sodium 3 plus is also 23 AMU. So our factor for the mass is 1, and therefore our factor for 1 over the mass is 1. So we filled out the right side of our factor line. We put an equal sign where the proportionality sign would have gone, and now we do 3 times 1 times 1 times 1 is 3. So our final answer is that our sodium 3 plus has a factor of deflection that is 3 times that of our neon plus. Thank you so much for watching, and I hope this video was helpful in solving this deflection problem.